Hello, everyone. Can you hear me? Can everyone hear? Oh, great, Reza. So I can hear, I can see people are already waiting for the session. I'm super excited today to have Reza Rahman with his presentation on effective Docker and Kubernetes for Java EE and, of course, Jakarta EE now developers. We have people from around the globe, which is super exciting and interesting. I will immediately hand it over to Reza so we can start the session. I can see the chat as well, and we will be monitoring to answer the questions. But Reza will give you the direction on how he prefers to handle the live questions. So that is everything from me. Reza, I'm handing it over to you.
Okay, perfect. So the first thing I'd like to do is talk a little bit about this, what this talk is about, and what the motivations are, and what we hope to accomplish together in the next hour or so. I think if you haven't read the abstract, I'll explain it a little bit more. So basically, this talk is about how to be effective as a Java EE developer using Docker and Kubernetes. There's a lot of FUD around there. The Java EE is not a good fit for these technologies and so on. The reality is very different. Not only is it a very good fit for these technologies, and I'll explain the reasons why that is, there's also many different trade-offs. There's many different things that you can do that is right for your particular individual situation. So that's some of those factors is what we're going to talk about. I'll give you a run through of what those are. The other thing, few other things I'll tell you is that if I actually went through the entire material of this talk, it would probably take about 2 hours. So there's definitely enough work here for a workshop. So I won't be covering, obviously, all of the materials today. I almost never do. What I'm going to do is I'm going to skip over certain parts, and I'll tell you why that's not a big deal. The reason that's not a big deal is this is the talk, as you can see. You can hopefully see my screen. The talk is essentially on GitHub. Believe it or not, in this talk, I won't be using any slides whatsoever. Literally, what I'll be doing is I'll be live coding for the next hour or so. But it's not entirely live coding. I'll basically be using the instruction set that's here to do the live coding. So what this means is, after the fact, you can just take a look at this this GitHub URL, and you will be able to replicate all of the demos by yourself. So that is one of the objectives of this talk. I do consider it sort of an open source talk. So you can self-guide yourself, take all the materials, do it yourself. And in fact, I always encourage you to maybe consider delivering this talk yourself. Certainly, all of the material is out there for you in order to do that. And of course, you can always reach back to me if you need anything at all, or need any guidance on how you could possibly deliver this talk yourself, perhaps internally, perhaps at a JUG, perhaps at a conference, what have you, even as a workshop if you so wish. So without further ado, let me explain the outline of the talk. First, I'll be just going over a basic Java EE application that I'll be using throughout this talk here. So that's under the Java EE folder. So there's some very simple instructions on how to get this application up and running. It's a basic CRUD application. So it's got all of the basic moving pieces that you would expect. It's using Java EE8 at the moment. Obviously, as soon as Jakarta EE8 is available, I'll be switching over to that. Can't do that quite yet for obvious reasons, but definitely on the roadmap for this talk. And hopefully one of the first talks I'll be delivering under the Jakarta EE umbrella sooner rather than later. Okay, so some basic instructions on how to do it. I won't go over this. This is, for most of us that are Java EE developers, this is probably pretty simple stuff. And I'll just run the application to show you how the application looks like. After that, we'll be talking about, for the most part, Docker for about half to three quarters of the presentation, we'll be talking about different ways that you can package and deploy Java EE applications using Docker. So we'll be using the thin WAR approach. That's sort of a favorite of Adam's, and certainly, honestly, a favorite of mine as well. You believe it or not, that's not the only option that you have in using Docker and Java EE applications. You can use Uberjars, so-called Uberjars or fat jars as well. I'll be showing you how to do that in using Java EE and what the trade-offs, some of the trade-offs there is. And there's also another very interesting approach called hollow Uberjars. And some Java EE and microprofile runtimes will allow you this hollow Uberjar option as well. So those are the three options that I'll actually be talking about. Those are the sort of the mainstream options that I've seen in use for deploying and packaging Java EE applications using Docker. The other parts that are sort of bonus that I would encourage you to take a look at yourself is the expose port and external volume techniques. I'll just briefly explain it here, and that's all I'm going to cover for those two techniques. And of course, again, you can take a look at this yourself later on. These are useful in conjunction with the thin WAR Uberjar and hollow Uberjar techniques, or as a separate technique altogether. So one is the expose port way of doing things. So what you do here is that you actually expose your admin ports for your Java EE runtime or application server. And you actually don't, in my example, I do deploy the WAR file and expose the port. But for certain runtimes, you can simply expose the port and simply use Docker, similar to how you would use sort of traditional VMs, and do your deployments via exposed ports the same way you would in a traditional on-premise deployment of a Java EE application server. So that's one of the techniques that you can consider, and it's documented on how to do that using Docker. It's a fairly straightforward technique there. The other interesting technique that I also have seen in use in the wild is using Docker external volumes. So most of the Java EE application servers, modern ones, provide an option for drop-in deployment. So you have a specific designated directory in the in your file path that you can simply deploy your WAR file or EAR file, and the application server will simply pick that up. There are advantages to this approach, and believe it or not, you can use this approach with Docker and Kubernetes as well. It's a fairly straightforward, again, way of doing things. There's a specific mechanism in Docker that will allow you to do that. It's called external volumes. And in the external volume section, you will see how to do that. And again, I won't cover it here beyond simply describing what it is. Finally, in the last quarter of the presentation, we'll be talking a bit about Kubernetes in the mix as well. So how does the entire Java EE deployment scenario look like with Kubernetes in the mix? There are some similarities and differences on how you do this vis-a-vis sort of a traditional on-premise deployment. But I think for the most part, it's actually an improvement. I'll explain to you why that is. Effectively, what happens with Kubernetes is some of the things that traditionally app servers control are then at this point controlled by Kubernetes. And actually, that makes, in general, things easier to deal with and more scalable and repeatable and all of the good stuff that Kubernetes comes with. Now, the one part of this talk that's still work in progress, and I haven't quite finished yet, is how to show all of this with CI/CD enabled, specifically with Jenkins enabled. I just haven't gotten a chance to get to doing that yet. Certainly, I would welcome a pull request to do that work. So as I mentioned, I'm using Java EE8 at this moment. I chose Web Shared Liberty for this demo, principally because it lends itself very well to all of the different techniques. But you don't necessarily have to use Web Shared Liberty. You can use, for the most part, any Java EE runtime, and by and large, you'll see the same sort of available techniques and trade-offs available to you. For the demo today, I will be using Azure. I'll be using the Azure Kubernetes service, which is a Kubernetes one of the leading Kubernetes implementations out there. You don't have to use Azure if you don't want to. It's everything that I'm going to be showing in this demo. You could easily apply to some other Kubernetes implementation, whether that's Google's or Amazon's or what have you. And obviously Jenkins, as I mentioned, I haven't quite gotten around to doing that as of yet. So let's start with demoing the application. So the first thing I need to do in order to demo the application is get the database up and running. This is a database-driven CRUD application. Actually, the simplest way to do that, since we're going to be using Docker anyway, is just start the database using Docker. So that's what I'm going to be doing. I'm going to starting a Postgres instance, essentially using Docker. So let's go ahead and do that. So if you've never seen Docker in action, this is generally how it looks like. And in fact, since I'm running Ubuntu, I need to add a sudo in front of it. Okay, so essentially, you say Docker run and do something. In this case, what we are doing is we are taking the Postgres image that is available on Docker Hub and essentially running it. And we're just giving the image a name via the -name parameter. And the /v is actually what I mentioned as the exposed or rather external volume technique. In this case, I'm using an external volume on my local machine that I need to store the data in, the actual physical data. That needs to reside outside of the Docker image. So I'll go ahead and get the database started here. Okay, so what's happening here is we are downloading the database from Docker Hub. It's getting downloaded locally. It's going to take just a moment, and once the download completes, it's going to actually start the database, hopefully without incident. So one thing I forgot to mention is that I don't tend to do separate Q&A at time. So I'd much rather go for depth rather than breadth. So if you have questions, just ask the questions. I guess using the chat mechanism in this case, and Tanya is going to ask me the question. Stop me and hopefully ask your question to me, and we can just do Q&A throughout. There's no reason to wait around. If I don't cover ground that I wanted, it's not a big deal. Again, all of the material is available to you. So if you have questions, don't hold back. Just ask them right away. So the database is now up and running. It's running locally. It is running on a designated port, as you can see. So if you look up into my Docker command, I have a -p parameter, and this is actually what's exposing the port. So when you are running a Docker image, by default, the image actually will not expose any of the ports. So think of this as a built-in firewall around the running image. In order to actually expose a port out of the image, you need to be very explicit about it. So in this case, we're explicitly saying, please expose port 5432 so that this port can be accessible outside of the running image. So there's the database up and running now, and we're going to go ahead and access this database. And actually, we're just going to keep the database up and running for a little while. This is my application. It's set up using in Eclipse. I'll just do a brief walkthrough of the application. And the best way to do that is actually in the GitHub itself. So if you bump back up, this is my Java EE directory. This is where the Java EE application resides. This is where the Java EE application actually is under the Java EE Cafe directory. This is really nothing much more than just a vanilla Maven Java EE8 application. Won't go through that code too much. You can do that by yourselves. I'll just show you the POM file because I think that's relevant. So I'm going to increase the font here a bit so we can all see it. So typical Java EE application, very, very simple set of dependencies. In this case, we just have a dependency actually just on Java EE8. Right, the Java EE API version is declared up here, as you can imagine. So other than that, there's no other dependencies. The build is super simple beyond that. So I mean, really, you can get much simpler in terms of a POM file. So very sort of Java EE situation here. You do need a little bit of server configuration, and the server configuration is under the server directory. So all you really need in this case is a database driver, and there's a Postgres database driver. It's actually included in the GitHub for your convenience. And you need some very small configurations for the application server itself. Not much. This is for the most part what you can see to expect in Open Liberty, or rather WebSphere Liberty, as a normal deployment. So in this case, I'm using, WebSphere Liberty comes with profiles or features. So in this case, I'm using the Java EE8 feature set. This is giving me all of the APIs that are in Java EE8. Other than that, I have some very simple configuration just for set up some security, some ports exposed. But the most important bit of configuration is here. I have a database, I have a data source configured. And the data source notice is talking to localhost and port 5432, which is the port that we exposed in our Docker image. Other than that, it's just a little bit of configuration just to register the database driver. Okay, so let's run the application. I'm going to just right-click and say run as, and then run on server, and it's going to start up Liberty. And if you've never seen Liberty run before, it is actually super fast to start up. So hopefully I don't bite my tongue here and it doesn't prove me wrong for some reason. Okay, so there we go. It started in 3.172 seconds, which I think is pretty impressive. So now we have the application up and running. Let's play around with the application just a little bit. So I'm going to go ahead and paste it onto my browser. I'm going to add a few. It's just a CRUD application. It's silly. It's basically a CRUD application managing coffee inventory. So we'll just add a few things here. We'll add Reza one. Oh my goodness. Okay, so I'm not sure. So here we go. The demo gods are not with us today, maybe. Let's see. Okay, target unreachable, cafe resolved to null. So looks like I have an issue with my JSF application. Let's see. Let's take a look. Okay, where is it actually? Let me do this. Let me just do sometimes this is just a caching issue that can happen. I'm just going to make sure that my code is fresh. So let me just take a look to see if there's anything I've inadvertently changed. So this is Java EE Docker. Let me just do a commit real quick and see if there's any differences. No, there's no significant differences. That's what I would have expected to happen. So let me just do a clean and build. So let me make sure Liberty is shut down. It is. Okay, I'm going to just do a run as and a Maven clean. Okay, and that should have cleaned up my WAR file. Let me just do a build now. Okay.
You can show the structure of the project.
Yeah, I can show that real quick. Let me just try to see if I can debug this and try to get the application up and running. And right after that, I'll show the structure. It's really not that complicated at all. Okay, there we go. Sometimes, as I said, there's sometimes I've noticed in Glassfish and Open Liberty, the application servers that are using things like OSGI, sometimes just things get cached and not flushed for some reason. So let me just show you. So there's the CRUD application. I'm going to hit delete here. Hopefully that works. It did. Okay. So let me add an entry just to show you that I don't have anything hidden up my sleeves. And hit submit. Okay, so everything is working. So there's a basic CRUD application. It's up and running as you would expect. So let me show you the structure of the application real quick. It's really not that complicated. So let me go back to the enterprise view. Okay. So what we have here, let me shut this down just so it doesn't interfere with anything else and I don't forget there's already a running instance of Liberty. So that's all shut down. So if you look at the source code, it's relatively simple. So you have essentially your Java sources. So source main Java, typical Maven structure here. So under web app, there's really not a whole lot going on. There's a resource. There's a single JSF facelet component for input price. There's not a lot in the webinf. There's a very simple webxml file. Not a whole lot going on here. Again, just specifying the welcome file for the most part. It's a very simple index.html file. The page that you saw there, basically this is a SPA, a JSF SPA, as a sort of weird as that may seem. It's just a single page application that allows you to do CRUD. And then there's some resources. Again, persistence.xml, fairly straightforward. Not a lot going on here either. Just a definition of the data source for the most part is the only interesting thing here. And under the cafe web, you have some messages properties that I'm loading. Other than that, it's just the Java code. And hopefully there's a better way of showing the Java code. Let me see if I can do that. Shouldn't have to. There we go. Okay. So under source main Java, there's several packages. There's a model, and under the model is just really just a repository. The repository code is just CRUD applications that allows you to essentially get, read, update, delete coffees using JPA. It's injecting the JPA entity manager. You have the actual entity, very, very simple. It's a coffee entity. It's just got three fields to it, ID, name, and price. And then we have a simple REST interface for it. There's a path for it. And then we have a get, post, and two gets. One is for get all and one get by ID and a delete. So those are CRUD interfaces for the REST. And there's also a JSF client, as you saw. So the JSF client is backed by a named bean. So there's a named annotation. It happens to be session scoped, and again, it just reflects, for the most part, just CRUD operations: get all coffees, add a coffee, and remove a coffee. Okay, so that's about it in terms of all I really wanted to show you of the application. In fact, we can shut down Eclipse altogether now. We don't actually need Eclipse to do any of the rest of it. We can just get away with the command line for the most part for the rest of it now. Okay, so now let's talk about, well, that's all good and fine, and stuff we've done for probably a good 20 years, 15, 20 years now, just building a WAR file and deploying it to an application server using an IDE in this case. So let's begin to take a look at, well, how do things look like when you begin to introduce Docker? So the first thing we're going to do is show the thin WAR approach to using Docker and Java EE, and I'll explain in a second what I mean by the thin WAR approach as well. But first, let me show you how the thing looks like in action. And then while that is going on, I'll show you some of the mechanics under the hood and how all of this is taking place. So again, we're just going to use the running database that we have here. We're not going to bother starting up another database instance. There's no need for it. What we are going to do is essentially actually package up the application. So if you noticed, basically the application consists of your WAR file, the Postgres jar file that we talked about, the database driver, and the server.xml. Okay, so that's really all you need in order to package up in one shape or form or the other. So we're going to just go ahead and package that up in Docker. I can show you how that looks like in action, and then after that, I'll show you how the code actually looks like to do that work. So right now, I'm in I have all of the code downloaded onto my local machine. I'm going to just cd into the thin WAR directory. So let me do that. So here we are. And first thing I'm going to do is actually so-called build the Docker image, right? So this is how that looks like. And again, I need to type in a sudo in front. So Docker build, and then I'm giving it the -t denotes a name for this image. And all I'm saying is that whatever is in the current directory, go ahead and build a Docker image in my current directory. So let's give this a shot and see what happens. Okay, so you'll notice first thing that's happening is that we are downloading Open Liberty, as you can see from my command line. So that's going to take just a moment. So that actually constitutes what's called the first layer of my Docker image. So we'll give it just a second here. It really won't take that long to happen. And then subsequent to that, there will be the other steps that we need in order to package up this application using the thin war approach. Okay, so in that step, what we did was we got the Western Liberty base image from Docker Hub. Now, what we're going to do, what we just did is copy over 3 files, as you can see. So here's the copy of the Postgres jar, and that's going into a specific directory in my Docker image, the resources directory. I'm copying over the server.xml, and that's going into the config directory. And finally, I'm adding the war file. And that's going into the drop-ins directory. And lo and behold, essentially my Docker image is now built, right? So everything that I would need in order to get this application up and running is packaged up into a Docker image. Now I can actually run the Docker image. So let me go ahead and do that. So we're going to go in here and simply say Docker run. Right? So this is, again, the command that you would use to actually run this image. So let's go ahead and do that, and then we'll analyze what went on here. So again, it's a Docker run. Give it the name of the image if you need to. Expose a port. In this case, we're exposing port 9080. That's the port that by default Western Liberty runs on. And we're giving it the name of the image that we had created before, which happens to be Java eCafe. So here we go. All right, and as you can see, basically exactly what happened, what would happen via an IDE, or if you're doing an on-premise deployment without Docker, and that's exactly what's happening. So Webster Liberty is starting up. It's reading the server.xml that I gave it. It just deployed the Java eCafe application. So if I went into my browser now and tried to access it again, rather, this is 9080, apologies. This is from another demo that I have. As you can see, my application is up and running again. Just to show you that it is that application that is running, I'll do a Control-C, and that's going to kill the running Docker instance. And if I try to load the page now, okay, as you can see, it cannot be reached. So let's take a look at the code a little bit and try to figure out, okay, what exactly happened here. So the Java application is actually, the Java E application is actually just as is. So all I really did here is behind the scene, a little bit before my talk, what I did was I built, and this is all covered in the instructions. Basically, what I did was I built my war file. And the war file is in the target directory. Here it is, java ecafe.war. And while I'm doing this, let's do this. I'll tell you in a second why I'm doing this. So I'm copying over the war file. This is the thin war directory. And what I did was I just copied over pasted over the war file here. And I'm going to do it again. And I'll show you in a moment why I did that. So other than that, you have a few artifacts that you need in order to build the Docker image. One is a server.xml. And this is basically identical to the server.xml that you saw before. The only difference here is that we are not referencing localhost. We're referencing this funky little IP address, 172.17.0.2. What is that? So basically what happens is Docker runs inside its own network. And all of the Docker images are given essentially a DNS assigned IP. So the very first image that starts is actually 172.17.0.2. So that refers to this running instance of the database. So that's how I'm able to resolve to that database. And this is a bit of a hack. You don't need to do this specifically when you're doing Kubernetes, and I'll show you why that is. In Kubernetes, you can actually get this dynamically assigned IP referenced for you, or you can simply reference a DNS name as opposed to referencing it by IP. So that's really the only big difference here in terms of server.xml. The Postgres jar you need because you need it to package up in the Docker file. And the big piece of magic really is the Docker file. So this is the guide that actually says what is in the Docker image. So this corresponds to the steps that we saw before. So we're taking from the WebSphere Liberty base image. This is basically all that is self-contained to be able to run WebSphere Liberty. So it includes a JDK, and it includes a default installation of WebSphere Liberty that happens to be Java EE8. You can be more specific and choose a different base image. And I'll show you that in a second when we talk about the other techniques of how you package up with Docker. But in this case, we're just picking the Java EE8 image, the default image for WebSphere Liberty. As you can see, we're copying over the Postgres jar file and copying over the server.xml, and then adding the Java E cafe, and then by default, that is all that you need to do. When the base image starts, this will actually start up WebSphere Liberty and actually deploy and run your application. Now, in Docker, each of these lines actually consists of a layer, and that comes in extremely handy for Java EE applications, because essentially Java EE application servers, the way they are intended is that they separate infrastructure concerns and runtime concerns from the application itself. And hence, you have the application server itself separated from things like the configuration, separated from things like the actual WAR file deployment. And in this case, we are simply deploying a very thin WAR file. And that actually works in our favor. I'll show you why right now. So you notice what happened when I built the WAR file the first time, right? So you saw that we went through all of the steps in order to build the image. Let's try to rerun rebuild the image now. So remember, while I'm doing this, I did do something. I did change something. Namely, I copied over the WAR file one more time. So let's assume for a second, the reason I did that is because I made some changes and I want to deploy a new version of the WAR, and basically I'm rebuilding my Docker image. So let's see what happens when we do that. Notice what happened here. It is a lot faster, right? This time, the image build is a lot faster. The reason is, read what's happening here in each of the steps, in each of the layers. So step 1 of 4, which is a WebSphere Liberty base image, it's already cached locally because I did it once. Same thing for the copy operation for the Postgres jar file. Same thing for the server.xml file, and same thing for everything else except for my last change, which is the actual deployment of the WAR file. So while this is impressive now, it's even more impressive when you have Kubernetes in the picture, because what happens is the way this caching and layering works is actually throughout the Docker and Kubernetes based system. So what this means is, if you are using thin WARs, you're able to do everything much faster. You're able to build your new image much faster. You're able to propagate this change to your application much faster. You don't have to actually upload the entire Docker image. All that actually happens is only the change part is updated all the way up to your Docker repository and all the way down to your Kubernetes deployment. So this is why the thin WAR approach is actually very, very good. And it works very, very nicely with Docker and Kubernetes-based deployments because of the way that it works very naturally with the Docker layering and caching. Okay, so I think that's all I really wanted to show you in terms of the thin WAR approach. The value of this approach actually becomes more obvious when you take a look at some of the alternatives. So let's now take a look at the Uberjar approach. So what is this Uberjar approach? I think it's best to show you rather than talk too much. I think that's a much easier way of showing you exactly what is going on. So in this case, what I have is there's actually I've copied over the Java EE Cafe application. The reason is there is several changes in the POM XML, the way that the POM XML is built. And I'll show you why that is in a second. The other thing you'll notice is, in this case, the Docker file is actually within the Maven application. This is actually the normal way you would do Docker usually. In the other cases, I'm just trying to make it a little bit more simpler. But this is the normal way of how you would have your project structure actually. So the Docker file is within at the same level as your pom.xml. So let's see what this guy does, right? And what is different about it. From a Docker standpoint, not much. It looks virtually identical, but what happens behaviorally is very different. So we'll see why that is. All right. So here's it. I'm inside my Uberjar directory now. I'm gonna cd into where I have the POM file installed, and I'm gonna just go ahead and do a Maven clean first, actually. And actually, I believe I need to do a sudo for that as well. All right, so that's done. Now I'm going to do an install. Now notice very carefully what happens here. There's some interesting stuff that will happen when I do the Maven install here. So what I'm actually doing is I'm building not a WAR file, but actually a fat jar. And this is the typical way you do a fat jar approach. The fat jar approach is done generally through Maven. So that's exactly what's happening here. So it's going to be a little bit different than what would happen in the thin WAR approach or pretty much any other approach of building a WAR file via Maven. So pay close attention. I will give you running commentary of what happens when I hit install. Hopefully things don't blow up. So first thing is very normal. We're just building the WAR file. So the WAR file is now built. Now what's actually happening is we're installing the server. So what is actually happening is we are going out and pulling Webster Liberty from a public repository and actually expanding it as part of my build. Next thing is we are actually copying over our files in as part of the build. So that's where that went a little bit faster than I was expecting. So let me talk through what happened here. So here's what happened. Up to this part here is the build of the WAR file. Over here, what's happening is we're actually downloading Liberty itself. Okay, so we're getting that from a location. I'll show you that in the POM XML how that happens. We're copying over the server.xml file that we need as part of the install apps command or phase. Then we are copying over the Postgres jar file. Actually, we're downloading it from Maven Central, in this case, the Postgres jar file, and then copying it over into a certain directory. And finally, we are packaging all of this up. Okay, so after we package all of this up, and this actually all happens, let me show you what the final output is. So let's do an ls, and you notice this funny little java-e cafe.jar. Okay, this java-e cafe.jar is actually a self-contained jar file that includes everything that you need in order to run this application. So it includes all of our configuration files, it includes the WAR file, and it includes the actual runtime, in this case, Webster Liberty. So I'll show you how that all works via Docker, actually. But before I do that, let me show you the actual POM file to show you how that looks like and how we actually created the fat jar. It's a bit involved. So as you can see, normal java-e jar file all the way up to here. Okay, then the interesting stuff begins to happen. So in this case, we are using the Liberty Maven plugin to do all of our work, to actually create our fat jar. In the configuration section, we are saying, please install the Webster Liberty Java E8 version and then download it as a zip file. We're going to finally package all of this up as an Uberjar called java-e-cafe.jar. It happens to be runnable. In the executions, you say, I want to install the server. And the most interesting thing you will say here is, where is my server.xml file? Okay, that I'm going to package up in my Uberjar. And then we are also, as I mentioned, using the Maven copy target to actually get a copy of the Postgres jar file and put it in a directory where we're going to package it up in the fat jar itself. Okay, so that is all the steps that is necessary in Maven to actually build this. So one thing you should have noticed is that this is a lot slower in building than just building a thin WAR file, obviously, because there's a lot more going on. But let's see how this looks like in Docker world now. So let's go up to and actually do the same thing. We're going to build a Docker image. and we'll actually run the application as well. So let's do that. All right, so here's my Docker image build. All right, so notice what's happening in this case. In this case, we're actually getting from OpenJDK. So we're not installing Western Liberty at all. Our base image in this case is OpenJDK. And then we are, next step we're doing is actually copying over the fat jar. You'll see that happening in a second. Yep, there it is. There's the add command for the actual fat jar, and then we're going to actually run the fat. We're going to expose port 9080, pardon me, and then we're actually going to run the fat jar itself. So let me go ahead and run this guy and show you how this looks like when you actually go to execute it. Execute this particular Docker image with the Uberjar in it. Okay, so there we go. All right, and it is back up and running. Let me just prove it by reloading this URL, and there's my application up and running once again. So now let's see how different or similar the Docker configuration file is, and what precisely are the trade-offs for this approach. So here's the Docker file. So you saw the POM file already, and you saw what was necessary to build the fat jar, and you saw that the Maven build is a bit slower than otherwise than it would otherwise. So this is the Docker file. So in this case, again, we're copying over not from Western Liberty, but from the JDK. This would be typical for a fat jar based approach. This is the first thing you would do. You would add the fat jar. In this case, we are adding the Java EE cafe.jar that we built from Maven. You have to explicitly expose port 9080 in this case, because that's a port that the fat jar will be talking on. And then finally, you do your java-jar command. And in fact, if I had more time, I'd show you. I'd actually run this without Docker, and you'll be able to see that this runs just fine. It runs as a self-contained jar. Now, notice what happens here. First of all, the Maven build is a bit slower. Second of all, take a look at what would happen if I wanted to make a change, right? So the layers here are relatively flat, right? So all I can cache here is this portion. So each time I need to make a change, this is the portion that will get executed over and over again. So in the end, you're transferring. So let me show you ls-la. And you can see the size of this file, right? It's quite a sizable file. So each time you do a Docker build, you're manipulating this much larger jar file. And to make matters worse, this is not just for the build. You know, when you go to do a deployment, when you go to upload your Docker file into your Docker repository, Docker registry, when you go to download this into Kubernetes, each time you'll be transferring a much larger file than you normally would for a thin wire-based approach. In my opinion, this is basically an anti-pattern. This is what you should not be doing using Java EE. This is probably you're working against the facilities that you have in Java EE in terms of being able to use a thin war. Right? So you're basically transferring over a lot of files. In fact, my opinion is this approach is actually more useful if you are not using Docker, but you want to have a Docker-like experience, because everything is essentially self-contained, and all you're relying on is the fact that you have a JVM, and that's all. With Docker, I think this entire approach is less compelling, in my opinion. So finally, let's talk about the hollow Uberjar approach and see what that is all about. Okay, so let's go ahead and do that. And again, the easiest thing to do is actually to show you instead of just talking about it. So we're gonna go and take a look at the hollow Uberjar. Sorry, I need to CD over one more.
So just to, I'm not sure you mentioned, but there is a question: what are the advantages of Uberjars, in your opinion? So
Uberjars really only make sense if you are frankly not using Docker. It gives you a self-contained executable. So basically, you need less setup in the deployment. If you're not using Docker, it takes less setup steps because you can just deploy the jar file and not worry about any of the additional setup steps. But this is with Docker, you don't really care, because at the end of the day, with Docker, you are deploying a Docker image. So that by itself is self-contained. It contains all of the steps that you would need in order to run your application. So it basically is Uberjar plus. It does what the Uberjar approach does and more. So in my opinion, there's not many advantages to using the Uberjar approach. If you're using Java EE, you're kind of working against what is available. You're working against what Docker and Kubernetes gives you in terms of the benefits of layering and caching. However, there's something to be said about this entire Uberjar stuff. And that's what I'll show you in the hollow Uberjar. And that's where you get some of the benefits of sort of this entire approach. So let's take a look at the hollow Uberjar approach, and then maybe that will help answer the question a bit better. So here's the hollow Uberjar approach. I'm going to, again, I've pre-copied over the WAR file. I don't need to do that. I'm just going to build my Docker image now. So let's see what happens here, and pay close attention, and I will also obviously give you some running commentary. Okay, sorry. Sudo, I keep forgetting I'm on Ubuntu, pardon me. All right, so in this case, what is happening is we are downloading from a separate Liberty image. It's called the Liberty kernel. So just what you need in order to run Liberty. And beyond, above and beyond, what you will now see is that this will take some time to execute, okay? Because what we are doing is that we are literally manually installing every single specific component of Java EE that we need. So right now, JSF 2.3 is being installed, and that's the installation step for that that is going on right now. And then JAX-RS 2.1, and so on. So this will take a little bit of time. So let's utilize this time and show you how the code looks like, and maybe I'll explain a bit what is going on here and why on earth would you want to do this. So first of all, let's take a look at the server.xml file. So one thing that should strike you is that in this case, we are calling out explicitly the features that we need. So we're not just importing Java EE8 anymore. We're explicitly importing the specific bits and pieces that we need for this application. And then the other thing you'll notice is that this is pretty small. There's not a whole lot of other configuration going on because there's nothing to configure, right? So we're starting from very, very simple. We're starting from the Liberty kernel. And then we're referencing only the parts that we need out of Open Liberty. So there's nothing to do other than just configure your data source. That's it. If you look at the Docker file, you'll see how this is enabled, right? So the reason this is enabled is that, again, we're taking from the Webster Liberty kernel, and then each of those features that I referenced, I actually have to explicitly install to say, hey, please, install that particular component only, okay? And then the rest of the steps are very similar to what you would have in a thin var. So we're copying over the database driver, we're copying over the server.xml, and we're copying over the var. So basically, this is sort of the best of both worlds. So one of the arguments for Uberjars is that, hey, why would you want to package up your entire application server? Why not have a Docker image that is much smaller and only contains what you need? Okay, so that's one of the arguments for Uberjars. And basically, this gives you that benefit. So I could have used an Uberjar here. I'm not, because I believe actually this hollow Uberjar approach in general is better if you keep it hollow, meaning that you don't actually install the WAR file within your fat jar. So you just install a customized runtime, if you will, And that's precisely what we are doing. And that the net effect of this is that it is reducing the overall size of your runtime. The actual runtime is a bit smaller, so your Docker image, in theory, would also be a bit smaller. How much smaller is frankly arguable, whether it's really worth the few megabytes that you gain by doing this. But in the end, you get a smaller Docker image by just installing exactly what you need. So let's see if this is actually done. Yeah, it happens to be done. Okay, so just to not scare you too much, let me copy over the WAR file one more time. So I'm going to just go over here and go over to the target directory and copy over the WAR file and go over to the Uberjar oh, sorry, not the Uberjar, pardon me, the hollow Uberjar, and copy over my WAR file one more time. So I'm pretending that I made a change to the application. Let's rerun this guy. Okay, notice what happened. Again, Docker layering and caching is helping us out in this case. So in all of those steps that you need to create a custom hollow Uberjar, well, that's all cached, right? So the second time, you don't have to incur the penalty of going through all of those steps. All of those steps are basically being retrieved from the cache. So in net effect, other than doing it the very first time, the performance in terms of the build performance and the deployment performance of this is very similar to what you would have in a thin WAR approach. Plus, you're getting a smaller, more efficient runtime in the end because you're only using exactly what you need. The trade-off, of course, is it's a bit more complex, right? So you need to know about all of these components that you need, explicitly call them out, and so on. Even if you're not using OpenLiberty and you're using some other similar mechanism for doing hollow Uberjars, the trade-offs here are basically the same. So I'm running a bit short of time. So I have just about 10 minutes. I won't have a lot of time to show you the Kubernetes, and I really wanted to do that. So I'm going to just actually just breeze through the Kubernetes demo real quick, and I won't have a lot of time to explain what I'm doing. Hopefully you get to read the instructions and be able to do this yourself. So over here, what I have Azure. So everything that I have everything set up already. So I have an Azure Kubernetes cluster set up. I'll blow this up a little bit more so you can see it. There's my little Kubernetes cluster, Kubernetes service, and I'm just going to deploy via Kubernetes, just so you can see how all of this stuff works when it's all put together. So I'm going to go ahead and create the database. In Kubernetes, you do all of this stuff by basically a set of YAML files, a set of Kubernetes scripts, if you will. First thing I'm going to do is I'm going to create my database. Okay, so my database is created. There's several steps in there in the Postgres.yaml file that will allow me to do that. Now what I'm going to do is I'm going to be a little bit clever, and I'm going to get the physical IP address of the database that is running on the cloud, and I'm going to save it into a configuration, what's called a configuration map in Kubernetes, and you'll see again all of these steps outlined in the instructions. You can use just DNS names as well. In fact, I'm going to probably change the stock to use DNS names as opposed to doing this technique. So I'm going to do that. So now I have a config map created with my IP address for my database. I've already built my Docker WAR file in there, so it's already sitting in there somewhere. I'm going to now do a Docker build the same way that I am. The only difference in this case is that because I ultimately want to upload this into Docker Hub, I'm going to give it my Docker Hub ID. And I'll free my Docker Hub in a second. Oh, sorry, sudo. I'm using the thin WAR approach in this case, so that's what's going on. I just built that, and I'm going to post this. So this is a step I haven't done before. I'm going to post this Docker image onto Docker Hub because that's the only way I'm going to be able to deploy it onto Azure. It needs to be somewhere public. It can't be on my local machine. So I'm going to publish my Docker image that I just built to my Docker Hub. This is what happens when you hurry up too much. All right, and my Docker image is getting pushed. as you can see, it's using Docker layering here as well. The first time it can't really cache anything, so it's going to basically do all of the upload all of the stuff. If you look at my Docker Hub account, I now have hub.docker. So this is my Docker Hub account. Okay, so in my Docker Hub account, I now have an image called Java EE Cafe. Next thing I'm going to do is I'm going to actually deploy this to a Kubernetes cluster, to my cluster. So I'm literally creating my data center. There's 2 instances of WebSphere Liberty that I'll be running. You'll have to take my word for it just for now, but you'll be able to see it if you look at the actual YAML file. So I'm creating 2 instances of WebSphere Liberty, both running this image that has my WAR file, thin WAR file built into it. So here we go. All right, my cluster is created. Now I'm going to need to wait just a little bit. So while the cluster creation is extremely fast, creating a load balancer in front of it is slow, right? And it's not just slow in Azure. It's slow in I've tried it in Google and Amazon. It's for some reason wiring all this stuff up into a load balancer is a little bit time consuming for some reason. So we're going to just watch and wait for the load balancer, what's called a service in Kubernetes terms, to come up. So let's do that. So what we're watching for is the external IP field. So it's going to take just a moment for the external IP to pop up. While that is going on, let me show you a little bit of the code if I can. So in this case, the Docker file is going to be very similar to the thin WAR approach. Okay, nothing very exciting there. The Postgres and these artifacts are basically going to be largely basically the same, except for one difference, which is, in this case, we are using environment properties. Okay, so for example, the host is in an environment variable. So we populate the environment variable to Kubernetes, actually. So this is a Postgres.yaml file. It's very, very simple. All that it really does is that it assigns a volume, which is some space in the file system on the cloud. And then it just takes the Postgres image and deploys it. And that's really all there is to this. And then we attach a service in front of it to make it available to the rest of the cluster. And in this case, we're using cluster IP, which means we're just literally exposing an IP, an internal IP address. This is how the YAML file for the actual WebSphere Liberty looks like. Right. So in this case, what we are actually doing is that we're pulling from my Docker Hub account. Okay, this is obviously I need to change that while running it, but it's pulling from my Docker Hub account and actually creating 2 instances, replicas 2. There's 2 instances of WebSphere Liberty running on my cluster, and it is front-ended by a load balancer. Okay, and the load balancer translates from port 80 to port 9080. So in fact, when we'll be accessing the external port, we'll be accessing port 80, not port 9080. And there's our external IP address. We're going to just copy this bad boy, and we are going to put it right here. Lo and behold, in this case, obviously there is no data because we're running on the cloud. It's not the same instance that I had running locally. And just to show you, if I took this out, there's WebSphere Liberty running. Right? There's 2 instances actually of WebSphere Liberty actually, and it's a round robin being load balanced. And in fact, in this case, I'm actually using a shared cluster. So that's all configured in here as well. I'll show you real quick. In the server.xml, if you look here, you see, I'm using something called HTTP session database, which means the session cache is actually in the database itself. So you can use clustering and load balancing. If I had a bit more time, I'll show you. I would have shown you how to upscale and downscale these images, right? And so increase the number of replicas, decrease the number of replicas, and how you would actually monitor and manage this cluster. I'll just show you again really quickly. So if I go into Insights. Or metrics. Okay, this will give you a bunch of information about what actually is going on in your Kubernetes cluster. So this is similar to what you would normally see in an application server console. And for some reason, I'm having trouble showing you it for some reason. Come on now. I think some things have changed a little bit, but you should have been able to see essentially some metrics around CPU and node usage here. I'm not sure. And yeah, I'm running out of time, so need to move on. So yeah, basically, take a look at this. You'll be able to see how this differs from your traditional app server deployment. It's functionally equivalent. It's just that Kubernetes takes over certain elements that the app server normally would. So things like, for example, management of nodes, remote distributed deployment. So if I was to redeploy this application, all of that would be handled through Kubernetes as opposed to application server native facilities. There's some management and monitoring capabilities that are built into the Kubernetes ecosystem and console and so on. So that's a bit of a replacement. So some bits and pieces are taken over by Kubernetes, and some bits and pieces remain with the app server. But most certainly, you can do all of this and do it relatively elegantly using Java EE and Docker. So that is all the time that I have for today, and I do want to try to stick to my time slot. So again, feel free to take a look at my Docker Hub image. Feel free to give all of this a try by yourself, and just to see what you see. And obviously, you're more than welcome to help me finish the Jenkins CI section as well. I'd love to get that going at some point. Obviously, that is going to be make us way above the timeline and really make this a workshop as opposed to just a talk. Okay, so thank you very much. I appreciate it. If there's a time, I'll take a little bit more Q&A. I'll leave my screen share open in case anybody wants to see anything specific. But for the most part, that's it for today.
So I've been monitoring the chat. There were a lot of conversations, but I don't think there are any specific questions. I think we will all need a little bit of time to absorb everything you shared with us and try it ourselves. And then looking forward to another opportunity to have you, Reza, on the Jakarta Tech Talks.
Absolutely, my pleasure. And anytime. I've got a whole bunch of cache of talks that I'm just dying to give wherever. So yeah, I'll be more than happy to come back.
Yeah, we'll keep that in mind. Okay, so everyone, thanks so much for joining, and I'm looking forward to talking to you late June. Okay, thank you. Bye.